Solar panels generate electricity through a process known as the photovoltaic effect, which involves converting sunlight directly into electrical energy. This intricate process can be broken down into several stages, encompassing the interaction of sunlight with semiconductor materials, the creation of electric fields, and the movement of electrons to generate a flow of electrical current. Here is a detailed explanation of how this process works and how solar panels are designed to harness sunlight effectively. A solar panel is composed of many individual solar cells, each of which is a small device capable of converting light into electricity. The most commonly used material for these cells is silicon, chosen for its excellent semiconductor properties. Silicon atoms are arranged in a crystal lattice, providing a structured environment for electrons to move. However, pure silicon is not an efficient conductor of electricity on its own. To enhance its efficiency, silicon is doped with other elements to create an electric field within the solar cell. Each solar cell is made up of two layers of silicon. One layer is doped with phosphorus to create an excess of free electrons, called N-type silicon, while the other layer is doped with boron, which creates a deficit of electrons or holes, called P-type silicon. The junction between these two layers is known as the p-n junction, which is crucial for the photovoltaic effect to occur. When sunlight strikes the solar panel, photons from the sunlight are absorbed by the solar cells. Photons are particles of light that carry energy. When these photons hit the silicon atoms in the solar cell, they transfer their energy to electrons in the silicon. This added energy allows the electrons to break free from their atomic bonds. These freed electrons then move through the silicon and are collected by the electric field created at the p-n junction. As the electrons move towards the N-type layer and the holes move towards the P-type layer, an electric field is established at the p-n junction. This electric field acts as a diode, allowing electrons to flow from the N-type side to the P-type side, but not in the reverse direction. This movement of electrons generates an electric current. When an external circuit is connected to the solar cell, this current flows through the circuit, providing electrical power. The overall efficiency of a solar cell in converting sunlight to electricity depends on several factors, including the quality of the semiconductor material, the design of the cell, and the amount of sunlight that strikes the cell. Manufacturers of solar panels continually seek to improve these factors to increase the efficiency and output of their products. The structure of a solar panel is designed to maximize the absorption of sunlight and the conversion of that light into electrical energy. A typical solar panel is made up of multiple layers, each serving a specific function. The top layer is a protective glass or plastic cover that shields the cells from environmental damage while allowing sunlight to pass through. Beneath this cover is an anti-reflective coating that reduces the amount of light that is reflected away from the surface of the solar cells, thereby increasing the amount of light that enters the cells. The next layer is the solar cells themselves, which are typically arranged in a grid pattern to maximize exposure to sunlight. These cells are connected by thin metal strips called busbars, which collect the electrical current generated by the cells and transfer it to the electrical connections at the edges of the panel. The back of the panel is usually coated with a material that reflects any light that passes through the cells back into them, further increasing their efficiency. When multiple solar cells are connected together in a solar panel, the electrical output of each cell is combined to produce a higher overall voltage and current. This combined output can be used to power electrical devices, charge batteries, or be fed into the electrical grid for use by homes and businesses. The electricity generated by solar panels is direct current, which is different from the alternating current used in most homes and businesses. To make the electricity usable, it must be converted from direct current to alternating current. This is done by a device called an inverter. The inverter takes the direct current electricity from the solar panels and converts it into alternating current electricity, which can then be used to power household appliances, lighting, and other devices. The entire system, from the solar panels to the inverter, is carefully designed to ensure that the maximum amount of sunlight is converted into usable electricity. This involves optimizing the angle and orientation of the panels to capture the most sunlight throughout the day and across different seasons. It also includes using high-quality materials and manufacturing processes to create durable and efficient solar cells. In addition to the basic components described above, modern solar panels often incorporate advanced technologies to enhance their performance. For example, some panels use multi-junction cells, which contain multiple layers of different semiconductor materials. Each layer is designed to absorb a different portion of the solar spectrum, allowing the cell to convert more of the sunlight into electricity. Another innovation is the use of passivated emitter and rear cell technology, which increases the efficiency of the cells by improving their ability to capture and utilize sunlight. Solar panels are also integrated with systems that track the movement of the sun across the sky. These tracking systems adjust the angle of the panels throughout the day to keep them pointed directly at the sun, thereby maximizing their exposure to sunlight and increasing their energy output. While tracking systems add complexity and cost to the installation, they can significantly boost the efficiency of the solar panels, especially in areas with high solar insolation. The process of generating electricity with solar panels involves multiple steps, starting with the absorption of sunlight by the solar cells. When photons hit the silicon atoms in the cell, they excite electrons, freeing them from their atomic bonds. These free electrons then move through the silicon, creating an electric current. The structure of the solar cell, including the p-n junction, ensures that the electrons flow in a specific direction, generating a direct current. The direct current generated by the solar panels is then converted to alternating current by the inverter, making it compatible with household appliances and the electrical grid. The efficiency of this process depends on the quality of the solar cells, the design of the solar panel, and the effectiveness of the tracking system, if one is used. Solar panels are designed to be durable and long-lasting, capable of withstanding various environmental conditions. The materials used in their construction, such as tempered glass and high-quality silicon, ensure that they can operate efficiently for many years. Regular maintenance and cleaning can help to maintain their efficiency and extend their lifespan. The deployment of solar panels has grown significantly in recent years, driven by the increasing demand for renewable energy sources and the declining cost of solar technology. Solar panels are used in a wide range of applications, from residential rooftops to large-scale solar farms. They are also used in remote locations and off-grid systems, providing a reliable source of electricity in areas without access to the electrical grid. The environmental benefits of solar panels are substantial. Unlike fossil fuels, solar energy is clean and renewable, producing no greenhouse gas emissions during operation. By reducing reliance on fossil fuels, solar panels help to mitigate climate change and reduce air pollution. They also contribute to energy security by diversifying the energy supply and reducing dependence on imported fuels. In conclusion, solar panels generate electricity through the photovoltaic effect, where sunlight is converted into electrical energy by semiconductor materials such as silicon. The process involves the absorption of photons, the excitation of electrons, and the creation of an electric current within the solar cells. The design and efficiency of solar panels have improved significantly over the years, thanks to advances in materials science, manufacturing processes, and system integration. Solar energy continues to play a crucial role in the transition to renewable energy sources, providing a clean and sustainable alternative to fossil fuels. As technology advances and costs continue to decrease, solar panels are expected to become even more widespread and efficient, contributing to a greener and more sustainable future.